Metalloids can be defined as chemical elements whose physical and chemical properties fall in between the metal and non-metal categories. Boron, germanium, silicon, antimony, arsenic, tellurium, and polonium are the seven most widely recognized metalloids.
Tellurium. Tellurium is a chemical element with the symbol Te from the first two letters of its name and atomic number 52.
It is brittle, mildly toxic, rare silver-white metalloid. Tellurium is also related to selenium and sulfur, and all three are halogens.
Tellurium is occasionally found in its native form as elemental crystals and is far more common in the universe as a whole than on Earth.
Its extreme rarity on the Earth's crust is due partly to its formation of a volatile hydride that caused it to be lost to space as a gas during the hot nebular formation of Earth.
Next to the list is antimony. Antimony is a chemical element with the symbol Sb from its Latin name stibium and has an atomic number of 51.
It is found in nature mainly as a sulfide mineral stibnite. Antimony compounds have been known since ancient times and were powdered for use as a medicine and cosmetics, often known by the Arabic name kohl.
The earliest known description of the metalloid in the West was written in 1540 by Venucio Berencuccio. China is the largest producer of antimony and its compound.
Metalloid is arsenic. Arsenic is a chemical element with the symbol As and atomic number 33. Arsenic occurs in many minerals, usually in combination with sulfur and metals, but also as a pure elemental crystal.
Arsenic is a metalloid. It has various allotropes but only the gray form. Its metallic appearance is important to industry.
The primary use of arsenic is in alloys of lead. For example, in car batteries and ammunition. Arsenic is a common type dopant in semiconductor electronic devices.
Germanium is a chemical element with the symbol Ge and atomic number 32. It is lustrous, hard brittle, grayish-white, and similar in appearance to silicon.
Germanium is a metalloid in the carbon group that is chemically similar to its group neighbors silicon and tin. Like silicon, germanium naturally reacts and forms complexes with oxygen in nature.
Because it seldom appears in high concentration, germanium was discovered comparatively late in the discovery of the elements. Germanium ranks near 50th in the relative abundance of the elements in Earth's crust.
Boron is a chemical element with the symbol B and atomic number 5. In its crystalline form, it is a brittle, dark, lustrous metalloid. In its amorphous form, it is a brown powder.
As the lightest element of the boron group, it has 3 valence electrons for forming covalent bonds, resulting in many compounds such as boric acid, the mineral sodium borate, and the ultra-hard crystals of boron carbide and boron nitride.
Boron is synthesized entirely by cosmic ray spallation and supernova, and not by stellar nucleosynthesis, so it is a low abundance element in the solar system and in the Earth's crust. It consists about 0.001% by weight of Earth's crust.
Metals. Metal are solid materials that is typically hard, shiny, malleable, fusible, and ductile, with good electrical and thermal conductivity.
Magnesium is a chemical element with the symbol Mg and atomic number 12. It is a shiny gray metal having a low density, low melting point, and high chemical reactivity. Elemental magnesium is a gray-white lightweight metal, 2/3 the density of aluminum. Magnesium is used in products that benefit from being lightweight, such as car seats, luggage, laptops, cameras, and power tools. It is also added to molten iron and steel to remove sulfur.
Magnesium was first isolated by Sir Humphrey Davy, an English chemist, through the electrolysis of a mixture of magnesium oxide and mercuric oxide in 1880.
Next is lithium. Lithium has a symbol of Li. It is the lightest of the solid elements. The metal itself is soft, white, and lustrous. Several of its alloys and compounds are produced on an industrial scale. It has a melting point of 180.54 Celsius and a boiling point of 1342 Celsius. Its density is half of water's density. Lithium was discovered in the mineral petalite by Johann August Artvidson in 1817.
Next in line is gold. Gold is a chemical element with the symbol Au and atomic number 79. It is a bright, slightly orange-yellow, dense, soft, malleable, and ductile metal in pure form. Chemically, gold is a transition metal and a group 11 element. It is one of the least reactive chemical elements and is solid under standard conditions. The melting point of gold is 1064.18 degrees Celsius and its boiling point is 2836 degrees Celsius, while its density is 19.282 grams. Gold is used in coinage and is a standard for monetary systems in many countries. It is also extensively used for jewelry, decoration, dental work, and for plating. It is used for coating certain space satellites as it is a good reflector of infrared and is inert. While historians and other experts still can't ascertain when or who discovered the first ever gold, it is believed that the metal was first found by the ancient Egyptians around 2450 BC.
Next one is silver. Silver is a chemical element with symbol Ag and atomic number 47, classified as a transition metal. Silver is a solid at room temperature. Pure silver is nearly white, lustrous, soft, very ductile, malleable. It is an excellent conductor of heat and electricity. It is not a chemically active metal, but it is attacked by nitric acid, forming the nitrate, and by hot, contracted sulfuric acid.
Copper. Copper was first used by man over 10,000 years ago. A copper pendant is discovered in what is now northern Iraq has been dated about 8,700 BC. For nearly 5 millennia, copper was the only metal known to man and thus had all the metal applications. Most copper is used in electrical equipment such as wiring and motors. This is because it conducts both heat and electricity very well and can be drawn into wires. It also has uses in construction, for example, roofing and plumbing, and industrial machinery, such as heat exchangers.
Non-metals. Non-metals are those which lack all the metallic attributes. They are good insulator of heat and electricity. They are mostly gases and sometimes liquid. Some of them are even solid at room temperature like carbon, sulfur, and phosphorus.
Hydrogen. Hydrogen is the chemical element with the symbol H and atomic number 1. Hydrogen is the lightest element. At standard conditions, hydrogen is a gas of diamotic molecules having the formula H2. It is colorless, odorless, tasteless, non-toxic, and highly combustible. Hydrogen is the most abundant chemical substance in the universe, constituting roughly 75% of all normal matter. Stars such as the Sun are mainly composed of hydrogen in the plasma state. Most of the hydrogen on Earth exists in molecular forms such as water and organic compounds. For the most common isotope of hydrogen, symbol 1H, each atom has one proton, one electron, and no neutrons.
Chlorine. Chlorine is a chemical element with the symbol Cl and atomic number 17, the second lightest of the halogens. It appears between fluorine and bromine in the periodic table, and its properties are mostly intermediate between them. Chlorine is a yellow-green gas at room temperature. It is an extremely reactive element and a strong oxidizing agent. Among the elements, it has highest electron affinity and the third highest electron negativity on the revised pooling scale, behind only oxygen and fluorine.
Bromine is a chemical element with the symbol Br and atomic number 35. It is a volatile red-brown liquid at room temperature that evaporates readily to form a similarly colored vapor. Its properties are intermediate between those of chlorine and iodine. Isolated independently by two chemists, Carl Jacob Lowick in 1825 and Antoine Jerome Ballard in 1826. Its name was derived from the ancient Greek bromos, meaning stench, referring to its sharp and pungent smell.
Fluorine is a chemical element with the symbol F and atomic number 9. It is the lightest halogen and exists at standard conditions as a highly toxic, pale yellow diatomic gas. As the most electronegative reactive element, it is extremely reactive, as it reacts with all other elements except for the light inert gases.